Hi everyone, welcome back. In this lesson we are looking at arrays of structures. So this is expanding on what we looked at in our previous lesson, so using the same project but I've changed it to use arrays of structures instead of the singular instance of a structure. So if we're looking at GVL here, we're still using DUT product and DUT calculator product, but you'll see now they are packed into arrays. And this lesson is just to highlight really the fact that we can actually have structures in arrays. There are some really big benefits of having structures inside arrays or as elements of arrays. They unlock the potential then to use for loops against function blocks or information being passed into function blocks, so you can process a lot of information via one function block on a loop and spit out the results, which is exactly what we're doing in this example. So we're familiar with this logic that we saw on the previous previous lesson, and like I said, all we've done now is wrap them in for loops. So if my sensors are active, then for 0 to 2, which will cover all three elements, I do the check spec and I pass in my GVL.product and then the I value, which is the index that my for loop is currently on. It shows 3 at the moment. I'm not quite sure why Codesys decides to do that, because it should be stopping at 2. It does stop at 2, but it shows the next element beyond in runtime when we're monitoring it. If I go ahead and turn on the flow control, you'll see it says 0 because we can only look at it on one scan of the PLC. Let me just turn that off so it stays familiar. So what we're doing here is every iteration of this for loop, we go and access our GVL.product and then each instance of this, which has different information, and we pass them through our check spec. And then what I have is in spec and a array of the same length, which is capturing our in spec. So if I go ahead and have a look at those values, we can see that only the first 2 are in spec and the third one isn't. And we could then go on and iterate over this array and check, which one was it that wasn't in spec, how many have we had that haven't been in spec, and all that sort of stuff, whatever our project requirements are with this information. But to do this, if we were to scale this up outside of arrays, if we weren't using arrays and we sort of had to pass maybe 1,000 products through per batch, that's an awful lot of information and calls to function blocks that we'd have to do to process the same amount of the same products through that logic. Whereas this approach is highly scalable. Our logic doesn't really need to change. All that would really have to change is our for loops and the amount of elements we're iterating over. In PLCs, we're not really able to dynamically check the length of an array. There's no like dot length or U-bound or anything like that. So we can either declare a constant here. If we had lots of these loops, for example, it might be better to declare an actual variable or constant that we can just update and all the loops would update. But in this instance, I would have to change this value here to say 1,000 or 999 or whatever it is, and my loop logic would then update. Nothing else has had to have been updated. We haven't had to add any new function blocks or instances or anything like that. We've just had to say loop over this extra data that we now have, and that in itself is a big strength. Not sure why that closed. So again, if I turn the sensors off, we are now running on our temporary data. So this is what we looked at in the previous lesson. I just wanted to show that the sort of approach still stands even though we are now using arrays. Notice that I'm still only using a singular T product or an instance inside my function block of our DUT product structure, and that's because I'm packing all of that information in per loop from our gvl.cp, which is our calculated product stuff here. So if I just expand these out, we can see that there's the individual values, and they are being loaded in per iteration of this for loop, but into the common temporary DUT product, which is T product here. So I haven't had to go and create an array of 3 of these. I've just been able to use the same one and load that information in each time. And again, I get my inspec, which is the opposite way around to if our sensors were active. So if I turn that on, you'll see those swap over, and turn them off, you'll see them swap back. So yeah, hopefully that highlights the sort of concepts of being able to use structures in arrays and unlock the sort of potential of being able to loop over those with a common function block or function, and iterate over those, and you can still collect data in the same way, and it's much more scalable, even more scalable than structures already are.